I show you first of all LCR circuit. After LCR circuit, I will come to RL circuit and LC circuit. LCR circuit. Let us see here. Now, let us how we can study the LCR circuit. You know, this is L, C, and R, and all three are connected to a EMF voltage. It is given by V0 sine omega t. This is L, this is C, and this is R. Okay, let us say here it is VL, it is VC, it is VR. I can show like this: V is equal to VL plus VC and plus VR. Okay. Now, how to study here? See, I can write now. See how to study the LCR. Now, see here we can do like this. See here we are having value of V like this. Now, to find the value of current here, see here, to find the value of current, what we will get? Suppose current I is flowing here. What will happen? This inductor will try that voltage. This inductor will try that current. This inductor will try that voltage should lead current. Voltage lead current. Capacitor will try that current will lead voltage, and this no choice. It wants that V and I should be in phase. We studied earlier also. What will happen? Due to this, their combined effect will get one I like this. I is equal to I naught sine omega t. There will be some angle phase difference come. Let us say it phi like this. Some phase angle will come and we'll say it like this phi. Okay. Now, how to find? Now we have to find the value of phi and value of I naught. This phi. From where we can find the value of phi? To find the value of phi, what we do is I show you using the phasor diagram. I represent it using phasor diagrams here. See here. How I do it? Suppose first of all we are having, see here, we are having current value. This is I naught. Okay, this is I naught. Oh, wait. Small, not so long. Okay, this is I naught. This is I naught. Okay. Now you see here what I did. Yes, you see here. This is I naught. You see, for a capacitor voltage, we know that it will be in this direction only. In this direction only. It will be here only. That is VR. Inductor resistance voltage in the direction of current only. And we know for inductor, we have remembered one word LE. That means voltage is leading current. Or you can remember one word, that is civil. This also we can use, that in capacitor voltage is in capacitor current leads voltage, and in inductor voltage lead current. Civil. For capacitor current lead voltage, and for inductor voltage lead current. You can remember by this also. No. Now, so for this, let's see here. For inductor, will try to do what? It will try that voltage should lead current. That means for inductor voltage will come along this axis. That means it will be VL in this direction. In the why? Because inductor will try to lead current. Current is this, so inductor will try to make angle 90 degree from here. You know this one? Now, for capacitor, what will happen? Capacitor, we know it is I. Or using here civil also, current will lead voltage. You can see here, current will lead voltage. That means current is here, it should be voltage. Voltage should be in this direction here. So that current is leading the voltage. I will write VC here. Okay. This all three are the voltage of the component of L, R, and C. Now let's suppose V is greater than VC. VL is greater than VC. What will happen? This one is greater than this one. What will happen? Here some component will remain. Okay, I show it like this. See here. Here. See here. I show here. I show you here. See. What will happen? Here it is. It was VR. Current was there I naught. What I have assumed here is here it was VC, and I have shown you that it was a VL, and VL was greater than VC. That means some resultant will remain in the direction of VL. That means I can show like this. This is suppose the resultant VL minus VC. Okay. Now the resultant of these two vector is this. Now taking the component of this one, resultant of these two vector, that is VR and VL minus VC, will get the value of resultant voltage in this direction. This will be the resultant value, that is resultant voltage, that is VR. And what will be the value of VR? It will be equal to under root VR square. Okay, I should not, I should write that like this. Only V. VR square plus VL minus VC whole square. And this angle is represented by phi. What was the phi? Phi was this angle. See here. Okay, and this angle represented by phi. Okay, now you should remember this triangle. What was the what we got the triangle? This is called as voltage triangle. This is called as voltage triangle. What is the voltage triangle? This represents VR. This represents VL minus VC here. This represents VL minus VC. And this we got as under root by using Pythagoras VR plus VL minus VC ka whole square. And this is represented by phi angle. That is phase difference. Okay. Now we can write, we know one more thing, that VR is how much? I into R. VC is how much? I into XC. And we know VL is equal to I into XL. Okay, these three we know. Now put all these three values here, or we can write like this. See, I can write like this using tan phi. What will the value of tan phi? Tan phi is equal to VL minus VC by VR. Putting the values, what we got? VL, put here I into XL minus I into XC by I into R. We can take the common I from numerator and cut it into two denominator. What we will get? We will get XL minus XC by R. That means we can say like this here. It also forms one triangle, and this triangle is like this. This is the value of phi, this is the value of R, and this is the value of perpendicular XL minus XC, and this will be equal to R square plus XL minus XC. Okay, and this is called as impedance triangle because all the three sides shows the impedance. Got it? Or have any problem till here? Any concept, any problem till here, you can ask. Then we will move further. If you have any problem till now, we can discuss it once here. Then I will move further. Any concept, any problem till now, you can discuss it with me here. Yes. Okay. Now let us see. One more concept I show you here. See. You can see here tan phi, this one. Okay. Now This is the resultant of resistance, and we say it as represented using Z, and Z is called as impedance, net impedance, total impedance. So we say total impedance, impedance, total impedance Z is equal to how much? It is equal to R square plus XL minus XC whole square. This is called as total impedance. Okay. Now you should remember this. Very important. Very important. This is also very important. This one also very important. Should remember that these are very important. Okay, I say this slide is very much important for you. Okay, very important slide. Okay, you should remember it. Very important slide. This was also very important slide. Okay, now we got the value of R. Now what we'll do, we can write here I is equal to V by R. Earlier we have studied that we have assumed V is equal to V naught sine omega t. Now we keep to know like this, I is equal to I naught. I have represented like this, I naught sine of omega t minus phi. I have represented like this. You remember this one? Now see here, it was general value plus minus 4, it can be here. You see here, if XL is greater than XC, or we can say VL is greater than VC, then we have studied that tan phi, that is phi is equal to tan inverse what? XL minus XC by X by R, or it is equal to tan inverse VL minus VC by VR. Okay, so I will represent it like this. I is equal to I naught, how much? V naught by Z. What is the Z? We know Z is equal to how much? It is equal to R square plus XL minus XC whole square, like this, Z here, into sine of omega t C. If XL is greater than XC, we came to know that our phasor is like this. This is the value of net voltage, and this angle is phi. So we will write omega t plus phi. Okay. And what is the value of phi? And this phi is equal to tan inverse XL minus XC by R, or tan inverse VL minus VC by R. Or we can say here, this was the net voltage and this was the direction of current. We will say here that when if VL is greater than VC, XL is greater than XC, we can say that voltage is leading current. Okay, this is for VL greater than VC. Got it, or have any problem till now? Any problem till now? Okay, got it, or have any problem till now? Because this was very much important concept. Okay. Now I show you in brief. Now you got the concept. Now I show you in brief. If suppose we have XL is greater than XC, XC is greater than XL. Suppose we are having VC is greater than VL. In LCR circuit only. In LCR circuit only, VC is greater than VL. What we will do? We can represent it like this. Okay. I draw the phasor first. You see here. This is the value of current. I represent it like this. I. Peak value is I naught. Okay. Now, for our circuit, resistance, voltage is in the same direction of the current. I represent it like this, and this is the value of VR. Okay. This is the value of we know. This is VL, and this is the value of VC and VC is greater than VR. VC is greater than VL. What will happen? We know that net resultant current will come in this direction, voltage or in the direction of VC only. So we can see that net voltage will come in this direction and this will be VC minus VR. And if you will take the resultant of both of them like this is the resultant. This will be the phi angle and this will be the net voltage. It will be equal to V naught sine of omega t minus phi. Okay, I can write like this. What if I is equal to I naught sine omega t? Okay, then V will be equal to how much? V naught sine omega t minus phi. That means we can show like this. And what is the value of V naught? This V naught is what? This V naught is equal to, or I naught is equal to how much? This is equal to V naught by Z, and Z we know the impedance formula. And this phi is how much? It is equal to, if you take out the triangle, this side is having VC minus VL and this is VR. So we can say phi is equal to how much? VC minus VL by VR. Taking IXC, IXL, IXC, IXL, IR. Cut all the i's, you will get XC minus XL by R. Okay, this is the concept, you should remember it. Okay, and we can say here for capacitor circuit, what is happening? See here, current is here, voltage is here. We can see that current is leading voltage by how much? By 5 phase difference, by 5 phase. Current is leading the voltage. Got it or have any problem? Till here, I have shown you the value of what is the concept of LCR circuit. If VL is greater than VC and VC is greater than VL. Okay. Okay. This was very important concept. Okay. So what is now after this? First of all, you should practice it once more. Many times practice LCR circuit. When XL is greater than XC, what will happen? XC is greater than XL, what will happen? And if both of them become equal, okay.